Welcome back to McCloud Academy. In our last video, we explored how DNS evolves from a simple internet phone book into a powerful strategic tool. We covered the core concepts from failover routing for disaster recovery to weighted and geolocation routing for optimizing user experience and ensuring compliance. Now, it's time to move from theory to practice. In this hands-on guide, we'll show you how to implement these powerful strategies using one of the most popular and robust DNS services available today, Amazon Route 53. In this video, we'll walk you through creating hosted zones right in the AWS Console, and then we'll configure DNS records to put these intelligent routing policies to work for your applications. By the end of this video, you'll have the practical skills to control your traffic, improve performance, and build resilient, highly available systems in the AWS cloud. Ready to get started? Let's dive in. AWS supports two types of hosted zones, public and private. To really understand the difference between public and private hosted zones, let's walk through a practical example. Here we have a simple two-tier application running inside a single VPC. The app server handles incoming requests, and the DB server stores the data. The app server has two IP addresses, a private IP to communicate internally, and a public IP so users on the internet can reach it. The DB server only has a private IP because it should never be exposed to the outside world. First, let's think about our users. We don't want them to type in a long, ugly IP address. We want them to use a clean, professional hostname like app1.mccloud.dev. This is where a public hosted zone comes into play. Its job is to tell the entire internet that app1.mccloud.dev should resolve to our server's public IP address. It's the public-facing front door to our application. Now let's look inside the VPC. The app server needs to talk to the DB server. We could hard-code the database's private IP into our application, but that's a bad idea. If the database IP ever changes, our application will break. Instead, we want our app server to use a stable, internal hostname, like app1-db.mccloud.local. This is the perfect use case for a private hosted zone. It's only accessible from within our VPC, and maps our internal hostname to the DB server's private IP. This is incredibly important, because it decouples our services. We can now change the database's IP address anytime we want, and all we have to do is update this one private record. Our application code doesn't need to change at all. So now that we understand the difference public for the outside world, private for your internal network, let's see how we can a public hosted zone from AWS Console. We will cover private hosted zones in a future video. Alright, now that we understand the difference between public and private zones, let's put that knowledge into practice. We're going to create our public hosted zone right now in the AWS Console. First, let's head over to the AWS search bar and type in Route 53. Before we click the link, here's a quick pro tip. Since you'll likely be using this service often, click the star icon to add Route 53 to your favorites bar for easy one-click access in the future. Okay, now let's open the Route 53 dashboard. From the menu on the left, click on Hosted Zones. This is where you'll manage all of your domains. To get started, click the prominent Create Hosted Zone button. This brings us to the configuration page. In the domain name field, I'll enter mccloud.dev. Next, and this is the important part, we need to confirm the type. For our purpose, we'll make sure public hosted zone is selected. This is what makes our domain name resolvable from anywhere on the internet. With our domain name entered and the type set to public, let's click the Create Hosted Zone button. And just like that, our public hosted zone is live and ready for us to start adding records. In the next section, we'll do just that by creating our first record using a simple routing policy. Simple routing is the most direct way to point a domain name to a resource, like a web server. This diagram illustrates the concept perfectly. On the left, a user types app1.mccloud.dev into their browser. That request goes to a DNS server, which, using the simple routing policy, gives back a single, direct answer, the server's IP address, 203.0.113.45. The browser now has the exact address it needs to connect to our application. It's a straightforward one-to-one map between a name and an IP address. To set this up, we need to create what's called an A record. In the next step, we'll do just that in the AWS Console. Okay, we're now looking at the details of our mccloud.dev hosted zone. You can see the default records AWS created for us. Let's add our own. Click the Create Record button to get started. This opens the record editor. We'll configure this step by step. First is the record name. We want to create the address app1.mccloud.dev. Since we're already inside the mccloud.dev zone, we only need to type app1 in this box. Next, we'll leave the record type as A, which is used to route traffic to an IPv4 address. Now for the value field. This is the most important part. It's the destination for our traffic. We'll enter our server's public IP address, which is 203.0.1.13.45. The TTLS or time to live, we can leave it the default for now. This just tells browsers and resolvers how long to cache the answer before asking for it again. Finally, under routing policy, you can see that simple routing is already selected by default, which is exactly what we need for this direct one-to-one mapping. Everything looks correct, so let's click the Create Records button. And that's it. Our S record has been created. Within a few moments, any request from the internet to app1.metcloud.dev will be routed directly to our server. In our next section, we'll explore a more advanced routing technique for handling multiple servers: geolocation routing. Simple routing is great when you have one server, but what happens when your user base is global? You wouldn't want your customers in Europe waiting for a server in the United States to respond. The delay, or latency, can lead to a poor user experience. This is where a much smarter policy, geolocation routing, becomes incredibly powerful. As we see in this diagram, all users still go to the same simple address, app2.metcloud.dev. However, the magic happens at the DNS level. Route 53 looks at where the user's request is coming from. If the request originates from the United States, DNS intelligently routes that user to the server at IP address 203.0.113.46, perhaps a server physically located in North America. But if the request comes from a user in Europe, they are automatically sent to a completely different server at IP2 03.0.113.47, which could be hosted in a European data center. The result? Both users get a much faster, lower latency connection because they are being served by a resource that is geographically closer to them. This is also essential for meeting legal requirements like GDPR, where you need to ensure European user data stays within the EU. So how do we configure Route 53 to perform this geographic magic? Let's dive into the console and set up the records for geolocation routing. Okay, let's bring our diagram to life. To do this, we'll create two separate AS records for app2.metcloud.dev1 for our US users and another for our European users. Let's start by clicking Create Record. We'll enter app2 for the record name. The record type remains AS. For the value, we'll enter the IP address of our US-based server, 203.0.113.46. Now, here's where the magic happens. Under routing policy, we'll switch from simple to geolocation. Notice that as soon as you choose geolocation, a new required field appears: location. This is how Route 53 knows where to send users from. From this dropdown, I'll select North America. Finally, because we're creating multiple records with the same name, Route 53 needs a unique record ID to tell them apart. I'll call this one US Users. Click Add another record. Great, one record down. Now we'll repeat this exact process for our European server. The record name is still app2, but this time, for the value, we'll enter the IP of our European server, 203.0.113.47. We'll select the geolocation routing policy again. But for the location, this time we'll choose Europe. And for the record IDs, we'll give it a different unique name, like EU users. Click Create Records. And that's it. We now have two geolocation records. Route 53 will automatically handle the rest, sending users to the server closest to them. Next up, we'll look at another powerful strategy for managing traffic across multiple servers: weighted routing. So far, we've seen how to route all traffic to one server and how to route users based on their location. But what if you want to test a new version of your application without sending all your users to it at once? This is a perfect scenario for our next strategy: weighted routing. Let's look at our diagram. As always, the user makes a simple request to app3.metcloud.dev. They have no idea that anything special is happening behind the scenes. This time, however, the DNS server has two records for this address, and each one has been assigned a weight. The first server, running version 1 of our application, app1 version 1, has a weight of 95. The second server, running our brand new version 2, App 1 version 2, has a small weight of 5. This tells Route 53 to act as a precise traffic controller. It will send 95% of the user requests to the stable, well-tested version 1. The remaining 5% of traffic is sent to version 2. This technique is incredibly useful for canary releases or A/B testing. You can roll out a new feature to a small percentage of users, monitor its performance and gather feedback, and then gradually increase the weight as your confidence in the new version grows. Now let's head to the console and configure these weighted records. Setting up weighted routing is very similar to our previous examples, but with one key difference. We'll be creating 2 records with the same name, but this time we'll assign each one a specific weight. Back in our mecloud.dev hosted zone, let's click Create Record. First, we'll create the record for our stable version 1. The record name is App 3, and the record type is A. For the value, we'll enter the IP address of our v1 server, 203.0.11.3.48. Now for the routing policy, let's select Weighted. As you can see, a weight field has appeared. The values can be from 0 to 255. For our stable version, we want to give it the majority of the traffic, so we'll set its weight to 95. We also need to provide a unique record IDs to differentiate it. Let's call this one app 3v1 stable. Now for our canary release version 2, let's click Add another record. The record name is again App 3. For the value, we'll enter the IP of our new v2 server, 203.0.11.3.49. We'll select the weighted routing policy, and this time, we'll assign it the remaining weight of 5. We'll give it a new unique record IDs like App3v2 Canary. And click Create Records. And that's it. Route 53 will now automatically send 95% of the requests to our stable server, and the other 5% to our new version. This gives us a powerful way to test new features safely. Finally, let's look at our last routing strategy, which is essential for building resilient, disaster-proof applications: failover routing. We've covered routing for performance and for testing, but what happens if your main server goes down? This is where our final and most critical strategy for ensuring high availability comes in: failover routing. This policy creates an active-passive setup, which is like having a safety net for your application. As our diagram shows, we have 2 servers, one designated as our primary resource and another as the backup. Under normal conditions, when a user requests app4.mecloud.dev, Route 53 performs a health check on the primary server. As long as it's healthy and responding, all traffic is directed to it. At the IP address 203.0.1.13.50, the backup server sits idle, receiving no traffic. But what if the primary server fails? Perhaps it crashes, or there's a network outage. Route 53's health checks will detect this failure automatically. As the diagram shows, DNS will immediately stop sending traffic to the failed primary server and will instantly reroute all incoming requests to the backup server at 203.0.11.3.51. This switch happens automatically and seamlessly, minimizing downtime and ensuring your application remains available to your users even during an outage. It is an essential pattern for building resilient, fault-tolerant systems. Now let's go into the console and configure this crucial failover setup. To configure a failover, we need to do more than just create records. First, we need a way for Route 53 to know if our primary server is healthy or not. We accomplish this with a health check. So, from the Route 53 menu, let's first navigate to Health Checks. Click Create Health Check. We'll give it a descriptive name, like App4 Primary Check. For the endpoint, we'll specify the URL of the health endpoint of our primary server to monitor, which is https://54.123.45.67/health. We can leave the advanced settings as default for now. Click on Create Health Check button to create the health check monitor for the primary server. Great! Now that Route 53 knows how to monitor our server, we can create our failover records. Let's go back to our mechcloud.dev hosted zone. We'll start with our primary record. Click Create Record. The record name is app4. The value is the IP of our primary server, 54.123.45.67. Now for the routing policy, let's select Failover. For the failover record type, we'll choose Primary. This tells Route 53 that this is the main, active resource. We need a unique record ID, so I'll call this app4 Primary. And here is the most critical step. Under Health Check ID, we must select the health check we just created. This links the record status to the health of our server. Now for our backup record, click on Add Another Record. The record name is still app4. The value this time will be the IP of our backup server, 54.123.45.68. We'll again choose the failover routing policy. But for the failover record type, we'll set it to secondary. Notice we don't associate a health check here. This record simply becomes active if the primary record's health check fails. We'll give it a unique record ID like app4 backup. And click Create Records. And with that, our resilient, fault-tolerant setup is complete. If our primary server ever goes down, Route 53 will automatically handle the failover for us. And there you have it, a complete tour of the most powerful routing policies in Amazon Route 53. We've covered everything from a simple A record to intelligent geolocation, fine-tuned weighted routing, and a resilient failover setup. You now have the practical skills to control your traffic, optimize for performance, and build highly available, fault-tolerant applications in the cloud. Thank you so much for watching. If you found this guide helpful, please give it a like. It really helps the channel. And if you want to see more content like this, be sure to subscribe and ring the notification bell so you won't miss our future tutorials. I'd love to hear from you. Which routing policy are you most excited to use in your own projects? Let me know in the comments section below. Thanks again for joining us, and we'll see you in the next video.